Okay, good morning, ladies and gentlemen. This is Professor David J. De Los Reyes. Let's have a long video format topic for this morning. So, in here, we got a problem. So, actually, we got the right triangle. I will try to see if it's visible. In here we are given a right triangle. The right triangle is this one here. This is the right angle portion. Okay. The hypotenuse is 24 inches. The base is 8 inches. The vertical height, this one here. What is just given is this height here. It is 6 inches. And the height of this one is just designated y. And this horizontal distance is just designated x. The problem is asking what will be the value of x. Okay. So actually we are given or we are looking for two unknowns to solve for x, or meaning to say to solve for x here we must have to solve first for y. Like what I said, the problem is asking what will be the value of x over here. Okay. I will try to lower my camera. I don't have a cameraman. I just do it myself. Yeah, it's like that. I focus a little bit the letterings or writings on the board. So the problem is asking for the value of x, this one here. Okay, let's try to bring out the solution. To bring out the solution of this one, we must have to use the so-called Pythagoras principle. Pythagoras principle. Like in any right triangle, if this is C, this is A, and this is B. And in any right triangle, the square of the hypotenuse should be equal to the sum of the squares of the two legs. For a right triangle, it got two legs, the horizontal leg and the vertical leg. Meaning to say the square of the hypotenuse should be equal to the sum of a square plus b square. So by using that principle, we could compute for y. Okay? So from the given right triangle, the hypotenuse is 24 inches. So the square of the hypotenuse should be equal to, okay, the sum of the square of the two legs. The first leg is actually this leg here, and we don't have any problem with that one because this leg here is given as 8 inches. So that will be 8 quantity square, the square of the first leg. And the second leg is actually this vertical height here, which is designated by 6 plus y, because this total height here is the second leg of the given right triangle. So the total length of the vertical leg is actually 6 plus y quantity square. So after using the so-called Pythagoras principle, we bring out a quadratic equation involving only one unknown, because the only unknown now is actually y. So if we try to simplify this one, we put this one on the left, so we write first y. Anyway, we could reverse the operation. 6 plus y is just y plus 6, so this one here, it will be y plus 6 quantity square equal to. This one here is on the right hand side, but since the unknown is actually supposed to be on the left, we transpose that to the left. So we maintain this one on the right, then we transfer it to the left, and this should now be equal to the square of 24. This one here should go to the left hand side, then we transpose it to the right, or rearrange it to be placed on the right. So this is minus 8 quantity square. Okay? Uh, 24 square is 576. The square of 8 is actually 64. 576 minus 64 is actually 512. And that should be equal to y plus 6 quantity square. The unknown y is actually inside the quantity. So to compute for y, I'll try to adjust my camera. I will lower down a little bit so could you see the calculation. Okay. The unknown is actually inside the parentheses, and the problem is it got a power 2. So to compute for y without these two here, we must have to raise both sides of the equation to the 1/2. Right? So y plus 6 quantity square, raise that again to the 1/2 power. We use the laws of exponent. These two here cancel with this. So the remaining power on the left hand side, after raising the left hand side to the 1/2, will just be simply 1. So it will now just be simply y plus 6 quantity. Oh, this is quantity actually raised to the first. But since this is 1, we don't have to write 1 first. It is understood to be 1. So the left hand side, after taking the square root, will just be simply y plus 6. And this should be equal to. For the right hand side, it should be 512 raised to the 1/2, or that will be the square root of 512. Right? So we eliminated already the power 2 on the left hand side by raising both sides of the equation to the 1/2. So what remains on the left will be y plus 6, and this should be equal to the square root of 512. And if we try to take the square root of this one, 512 is not a perfect square. It should be 20 plus. And what comes out is 22.62. If we try to use our calculator, okay, this is a scientific calculator, we just display 512. Then we'll try to take the square root of that one, that will be 22.62. So this is 22.62. So y now will be 22.62. We transpose this one to the right. This is minus 6. So 22.62 minus 6, that will be 16.62. So the value of y here is 16.62. Inches. So this overall vertical height of the original right triangle is 22.62, that is 16.62 plus 6, the overall height. Okay, so to compute now for the value of x, okay, since x here is parallel with the base, okay, if we try to designate this one as alpha, the lower angle should still be alpha. Okay? These two lines here are actually parallel with each other. Okay, and this line here is just same line from this portion here up to here. So same line, parallel lines. So if this is alpha, this should also be alpha. Could you see it, guys? I'll try to raise the figure a little bit so you can see it. Okay, that's the original figure. So to compute for the value of x, we'll drop a vertical line here. Vertical line meaning this is a vertical line, this is a vertical line. So this angle here should be 90 degrees and this should also be 90 degrees. So if we try to drop a vertical line here, okay, we could redraw two right triangles. This will be alpha. This height here is actually y, so this is y. And this length here, for the meantime, we do not know this length. So if the total length of the horizontal leg is actually 8 inches, okay, this portion here should be 8 minus x. So this should be 8 minus x. Okay? So the first right triangle should be 8 minus x as the first leg, 8 minus x, and this is y, and that's alpha. And the second bigger right triangle, the upper one, this one. The horizontal leg is actually x. This is still alpha. And the vertical leg of the upper right triangle should be this one. So this is 6. Okay? And from these two, what you call this, resulting right triangles involving the unknown x and y in alpha, we could now formulate an equation to compute for the value of x. I'll try to lower than this one so we could see the computation. I concentrated the camera on this portion here. So by using the first right triangle, we could compute for the tangent of alpha. Tangent is actually opposite over adjacent. So considering the first smaller right triangle, tangent of alpha will be y over 8 minus x. It is this. Tangent of alpha will be y over 8 minus x, considering this one. Okay? And for the second right triangle, again, we will take still the tangent of alpha, because if this is alpha, like what I said, this will be same as alpha, because these two lines here are actually parallel. Again, we will take the value of tangent of alpha using the second right triangle. So it should be the ratio of the opposite over the adjacent considering alpha. So tangent of alpha using the second right triangle, it will be 6 over x. Okay? Since there are 3 variables here, we must have to eliminate the third one to compute for the required value of x. So equating the value of tangent of alpha equal to tangent of alpha. The value of tangent of alpha using the first right triangle is actually y over 8 minus x. This is y over 8 minus x. And the value of tangent of alpha using the second right triangle, it will be the ratio 6 over x. It is this. Like we equate these two equations here. That is tangent of alpha equal to tangent of alpha. So after equating tangent of alpha equal to tangent of alpha, we could visualize that the resulting equation is now a linear equation involving x and y. And luckily, we know already the value of y. We know already the value of y. So if we know already the value of y, since it's a linear equation, we could now compute for the required value of x. So we cross multiply this one here. So 6 times 8 minus x, it will be the left hand side. And the right hand side will be the product of x and y. X times y. And like what I said, luckily we know already the value of y. The value of y is 16.62. Okay, so if we try to simplify the resulting, this is now a linear equation involving the unknown value of x. So if we try to expand the left hand side, 6 times 8 will be 48, 6 times minus x will be minus 6x, and the right hand side will be the product of y times x, or 16.62. I write y ahead because it is the pure constant term times x. And as you can see, after substituting the value of y to be equal to 16.62, the only unknown now will be the value of x. So it's just a matter of algebraic simplification now. So 48 now, okay. We will transpose this minus 6 to the right hand side. So it will become plus 6x. So we could remove this one now. This is 16.62x plus 6x. That will be 22.62x. Okay. This is these two terms here are similar. The variable portion is x, and the pure constant term, we add that. So it will be 22.62x, and this should be equal to 48. And to compute for the value of x, we must have to multiply this by 1 over 22.62. So for the right hand side, to expedite the solution a little bit, this 22.62 cancel with this. So what remains on the right hand side will be just be simply the product of x times 1. Or we could now transfer this one on the left. So x now will be equal to 48 times 1 over 22.62, or just simply the ratio of 48 over 22.62. And if we try to divide this one, 48, so our answer will be 2 plus, and what comes out for the value of x will be 2.12 inches. So this value of x here is actually 2.12 inches. So that's the value of x with all these given conditions. That is, if the hypotenuse here is 24, this is 8, and this is 6, okay, what will come out for the value of x will be 2.12. Okay, that's it, guys. So our topic for this morning will be a combination of triangles and some algebra portion. So actually, this is a subject matter under algebra and trigonometry. It's just a reprisal because for a long time, we haven't got a long video format topic on mathematics. Okay, so for those of you who would like to subscribe to my channel is at youtube.com/@ProfDavidJ De Los Reyes. If you want to share it, please click share. Good morning from Los Angeles.